Welcome everyone to our series of multi-agent system, and this is the first session to give you an overview of the multi-agent system. This paper is a review paper that is published about a year ago, and which is already having around like 150 citations so far. So I think this paper is a good quality and can help you establish the framework around the multi-agents. And in the upcoming series, I also plan to have more walkthrough of some interesting recent paper published. And also I want to look into some of the open source frameworks and applications, and maybe we have some fun with the hands-on practice as well. The first question actually I have is, what is the agent? In my mind, the agent is first proposed from the reinforcement learning, which was first proposed, I guess, in 60s. So it's 80 years ago. So I would say the agent concept was originated from reinforcement learning. So in reinforcement learning framework, people usually talk about, oh, this is a reinforcement learning agent. So what that agent actually is, it is an autonomous entity, meaning that it can able to directly interact with the environment. It's going to receive the observations or rewards or penalties from the environment, and also it's going to learn the kind of the optimal policy for the decision making. And then the agent may also have access, to different set of skills or tools it can call fully automatically. And also the agent may have its own memories, and also it has the goals that it wants to optimize toward. So I would say any agent, you see this framework is very similar to reinforcement learning, right? So maybe that's why it's called agent. Uh, and this agent is like fully able to also to execute some actions and to the environment, and it's going to observe. So basically, human is the agent, right? We are all autonomous. We can explore the environment, and we can adjust our behaviors based on the feedbacks we receive. And then more specifically, what is a LLM agent? So to understand the multi-agent, we need to understand the single agent. So the single agent is basically just one LLM model. So you can think of it just like a one LLM, able to invoke various sets of tools and also has access to a database. Say, like if you understand the RAG, right? So you can think about the vector database as the memory for the LLM to retrieve the relevant information or retrieve the experience from the past. And then the LLM can also use a variety of tools, such as like search the web, write Python and execute Python codes on the fly, and it may also invoke other AI tools, which can be another LLM. And so this is an example. I have also presented one meetup just on LLM using tools. For example, like the input is translate this to pick Latin, while the LLM may have no idea about, okay, how to do the translation. The first step is maybe just to call the search tool to say, okay, how can we write English as pick Latin? And then this is some response from the search engine. And then the next step is the LLM. So, oh, I want to write the code according to the search results, right? And then just write the code to translate this. And then it will start writing the Python codes, and this is a return from the tool. And then the third step will be just execute the code, and then you will get a response. And then the LLM, that's the end of the steps. I can conclude, and then it's going to respond the final sequence as a response to the input. So basically, the LLM agent is able to break down the task step by step, and is able to identify and call the right tools to complete the task at each step. So that is a single agent. What is the multi-agent then? So I think the Motivation is people identify that a single agent may get overwhelmed by very complicated and large-scale tasks. We cannot fully just depend on one LLM, like one model, to like complete the full, to reach the autonomous state of the system. It's just like a one person, right? So you can think about our agent as a person. It's like if one person get too many tasks, it's not able to complete that task very well. And then people start to say, oh, okay, why not like adding more agents to it? It's like building a team, all right, of agents. And then each agent can has its own specialties and it has its own set of specialized tools. And then we want the agent to really, really just focus on that goal, on that specific, very specific goal instead of a general LLM assistant. Right. So, for example, you may want to have a planner. This is your team leader, right? And then you want to have researcher who can do the web search and run the summaries, and then the analyst who can analyze the data, access the database. You can have the writer who can write you the report, and then in the end, you may still want to do some proofreader. Is kind of the quality check, right? So basically, you build a team of agents to complete the task, and then each agent is going to collaborate with each other to ensure that you have the most precise outcome from the team. Okay, this is the motivation of multi-agent. And so this is the answer from ChatGPT. So if you ask what is the advantages of mass multi-agent over single agent, it says first is it may have specific specialization and expertise. You will get more precise outcomes, and also it enables parallel processing because it's like multiple agents and multiple tasks can happen in parallel, right? So that you can improve the system efficiency and able to get to the final outcome faster. And also improve the robustness and reliability because right now you're less depending on just one agent. And by spinning up a system of agents, so we can do a more like error prone and more robust. And also it's will become more flexible, especially in a dynamically changing environment. One agent, like one goal, one agent, sometimes even the goal is not that clear enough, right? So we want to have a system that is able to dynamically adapt to the changes in the environment. So ideally, new agents should be introduced on the fly according to the environment feedbacks to fill the gap to address the new challenges. It's like a company, right? So you identify, oh, there's a bottleneck, oh, there's a new challenge to be solved, and then you may want to hire another headcount to fulfill the task so that the team can operate better. There is also something talking about collective intelligence, but I think this is a very hot research topic right now. People are still exploring to say whether this multi-agent system can lead to this collective intelligence, like to optimize the agent design system, dynamic orchestration that can lead to this collective intelligence by itself. Cool. And then before I look into the paper, I also look at, okay, what are the most recent very cool multi-agent system, especially the open source ones, that people have been developing. The first one coming into my mind is called MetaGPT-X. It is released in February this year. Although they have a MetaGPT, which is released, I guess, 1 year ago. The idea is providing the first AI software company. So the whole the multi-agent is targeting the full software team, including the product manager, project manager, software architect, software engineers. And so these are the profiles of the agents, and then you just give them an idea. Say I want to So one idea I want to try out is I want to write a code that can automatically create the meetup slides from the paper. So that's one idea I want to try out with this, and just to see how they can design the features, how they can break down the task, and have the engineering design, and then have the engineers and also the test engineers agents to complete the codes to complete the task. I think you can search and you will find a lots of interesting stuff from this application. The second one I also want to point out, this is also a paper published, I think, in March from MIT. It is a science lab, like material discovery lab, and then they call it atom agents to discover new alloys, through the physics-aware multimodal multi-agent AI. So basically, it's like how we can use the multi-agent to facilitate the full science experiments, so that we can speed up the material discoveries. And in their system is also multimodal, which means that their input data is multimodal. It can be text experiments, it can be material database. So this is like a domain knowledge. It can be some series like paper books, and also some like results, say computations, which can be a graph input, right? And then there will be a multi-agent system. They will analyze all the inputs, and they also have access to a set of tools, such as like to run the physics simulations and do the data analysis. And then the agent will do the reasoning. So basically, it's LLM. It's going to do the reasoning. It's going to plan how to run the experiments next. It's going to retrieve the most relevant materials or the theory in the memories. And also, it's going to do the self-correction and improvement on the fly. So yeah, I think this paper is also very interesting. It's coming out very fresh, and I may also want to plan one meetup on this. Uh, so I guess you have all heard about Manners. Manners AI is also a general AI agent that wants to bridge the minds and actions. It doesn't think, it also deliver results. So if you go to the manners.im website, you can see all the use case galleries over here. And you can click on it and see it happen in a live. And it's very interesting to see the outcome. So you just upload, for example, on the on-store operation analysis, you just upload a CSV file, a table, and then it's going to analyze, okay, what are the trends, what are the key findings, discoveries, what are the outliers from the past month's sales, right? And then it's also going to give you recommendations to say, oh, for the next month, if you execute these strategies, say to do a promotion, advertisement, and watch out certain stuff, your revenue is expected to increase by 10%. So it's not just doing the data discovery analysis, it's also doing prescription optimization and kind of like a consultant to the users. I mean, if it's going to work, then I guess it's going to replace lots of roles in data analysts and consulting industries if it's going to work. But I think it's a promising direction application of this. And so this is in the Manus AI, they also benchmark their performance on GAIA, so it's a general AI assistant benchmark. They compare it with the deep research, OpenAI deep research, and it sets to improve the performance. So from level 1 to level 3. So basically, the higher the level, the more complicated the task is. And it's able to show that it's able to has a better performance comparing to the deep research with just one shot performance on this benchmark. Okay, so that's the Manners. And if I search Manners, another thing shows up. It's called OWL, open, and it's open source. And people say that this framework is able to beat Manners. So that's how competitive it is right now. So like you have something out, like whether closed source, especially closed source. And then soon there's the open source framework saying, oh, I'm going to get you a better performance with this open source. And this our open source framework is from Camel AI. The idea is for this startup is to have a Hugging Face like platform for AI agents. So Hugging Face is kind of the platform for all the machine learning models, right? And then Camel AI, the idea is that they want to be the platform community for the AI agent builders. And then this our open source framework is also like a multi-agent framework. And they're able to achieve also a very high score on this the same benchmark, a general AI assistant benchmark out there. So if you want to try the open source version, so this is the one to go there. I think they also released it very recently. I guess after a month, the landscape is going to change. More framework companies will show up for this. Cool. It's a very exciting field. Okay. After all that, hope you are excited about the potentials of multi-agent systems. So first, I just want to pull out what is the major components in the multi-agent system, right? So there is some system design in the beginning that you need to. I see lots of application right now that the initial agent setup is still designed by human, right? So the human create roles because human know how team works. So you may, for each agent, you may need to define the profile, what is the goal, say what is the goal for engineer, right? And how it's going to communicate with the other agent. So this will deals with the agent communication, what is the structure of the agents, and also how the agent is going to improve, how it's going to adjust itself based on the feedback, and then it may need to adjust its action. And then there will be also a layer of agent orchestrations to see it's not just a static set of agents that we may need to create new agents to focus on the new problem that is observed on the fly. And then within one agent is just one LLM model, right? So this is all the I would say just all the memories for the LLM, right? So it's kind of like you provide the profile instructions to the LLM. It's kind of all the memories for the LLM. Well, there also can be some long-term belief uh, which you can store them in the vector database, and then you can always retrieve the most useful, successful examples for the LLM in order to improve the performance for that specialized task. And then, yeah, so basically this LLM agent system is still very similar framework to reinforcement learning, where you will just execute it in certain environment, and then you will receive the observations and feedbacks from that. So first, so you remember here, I like 1, 2, 3, 4 components, and then this is what the next slides are organized around. So the first is the agent environment interface. We need to set up like what is the environment that the agent is going to interact with. So environment can be a software developed environment, right? So in order to develop software, you need to have that software development for the engineer agent to execute codes, to receive the errors from the execution, and is able to readjust the code, execute again. And also, you need to have the QA agents to run the unit tests and all of that. Gaming, yeah. So the gaming is like the gaming, the video games and all of that. So the agents also need to be aware of all the surroundings. I think they all share the same virtual world in the games. And also the financial market, you may also want to set up if the agent is for the trading, right? For example, you may also want to set up the financial market for the agents to make action. For example, they want to trade stocks and then observe after one day what is the rewards, right? So basically, we need to have based on the problem you have, you need to set up the environment for the multi-agent system so that they can make action and they can observe the response from that. So that's the purpose. There are many three types of environments. So this is described in that paper. Maybe it's going to change over time. But this is like what you describe in the paper, like a sandbox. I think it's very usually commonly used in for software development. It can be a physical world, especially for that will obey all the real world physics and constraints such as robotics environment. And it can be also none. So some agents do not need an external environment. So for example, if you want to host a debate, you can just ask the agent to debate with each other, or play the chess, right? So if you see, I think there's a very interesting video showing the chess play between ChatGPT and DeepSeek, and to see how crazy that chess game going to be in the end. So it's like you just ask the two agents to debate and compete with each other and to see the final consensus and outcome. Okay. The second component is agent profiling. So basically you need to define the initial agents, what's their traits, what's their goals, actions, and skills. How people set up the agents is also usually right now it's like initially predefined, right? So it's explicitly defined like the initial prompts and goals and like uh, well, human can also write this profile by using LLM, right? So it's like, oh, I have this problem, and then I want to solve this problem, and then the LLM may also automatically generate some of these profiles. It's like kind of like a model generated, like just describe the problem and go, and then the LLM may figure out, oh, I need these different roles, and thus we have these different types of agents to corresponding to those roles. And also it can be data derived, but I think it's very rare. I do see a few applications. The paper also mentioned a few applications that is the data-driven approach, based on, I guess, based on the different types, different categories from the data it shows, it automatically figure out, okay, what type of agent it needs, which also makes sense. So this is an example. If you use the software, like the AI software company as example, right? So you may have your, I would say this is a CEO, CEO there. So it's kind of like doing the invest. It has a key idea how we can win the market. And then you may receive the feedback, say, according to the AI software company, the sales and how frequent the users interact with their service. And then there will be the boss, I would say the manager, right? Like the requirement to the team. And there will be product managers to write the product requirement descriptions, and they can also revise it according to the feedback they receive from the boss and CEO. And then, and then there will be architect role to write all the design diagram, and it's going to review the PRD from the product manager. And also it may initialize some framework codes, right? And then there will be project manager is to manage all the tasks, to say, okay, which task, what are the steps to execute the design there. And then it's going to coordinate with the engineer to write the specific modular codes and functions for the engineering design. And in the end, you will have the QA agent to write all the tests, small and integration tests for the codes. So that's your full AI software company profiles. So once you set up the agent profiles, the next is how the agents will communicate. You already see the examples in the AI software company, right? So for example, the architect needs to read the design from the product manager, and engineer also need to read the design from the architectural design and also need to understand the PM, right? The specific product requirement there. And also QA needs to read the codes from the engineer. So basically, there will be interaction with agents, and also there are several communication paradigms, such as like cooperative, like all the agents work toward a shared goal, such as software development. It is working toward the same goal to implement the product, right? So, and also robotics is towards a shared goal. And it also can be debate. such as the legal case. I think it's very interesting. Like if you want to do some legal kind of simulation, like to defense at the court, then the AICC legal, you may set up different agents like the on two sides and also the uh like the judge, right? And then you will see the play, and then you may notify, oh, I should be better prepared for that question ask. Uh, over there, etc. And also there will be a scientific discovery. I think it's also good to use the debate to see what are the potential, like kind of for brainstorming of the ideas and both cooperative and debate to see what are the next best strategies for the or actions for the science discoveries. It can be also competitive, especially for the financial companies that they and also cybersecurities, right? It can be competitive between the agents so that you can win in the competitive market. Say you put out action and then you may have an agent to play the role of your competitive company. It's kind of a game theory, right? So you want the agents to be competitive and then uh, act based on the assumptions of the other competitive agents. I think it's a very interesting to set up the framework and just to see what is the final outcome as a game play over there. On the communication structure, this is about how you want to make the collections of the agents. It can be layered like this. It's kind of like a neural network, multi-layer neural network. So over here, the example is like an industrial automation, right? So the low level can be robotic, motor control. Middle level can be machine coordination. High level can be factory-wide production, job scheduling there, right? So if your task has this multiple levels of granularities, you may also have different set of agents at different levels. Decentralized. One example is like this is kind of like the uh it is kind of like there's no centralized, so the system is very robust and it's very useful for the disaster relief. For example, the drone fleets, like you have lots of drones for the disaster relief, and each drone should also independently map to the affected areas without too much central controller. Well, the drone may also be aware of the locations of the other drones so that it can make the right planning trajectories. So if one drone is off, it's okay. The system won't be impacted that much. The third one is centralized, that you have a centralized planner in the beginning, which means that, so this is, for example, you want to optimize the logistics system. We still need a central server to plan the drivers, plan to optimize the route, and also according to the demand, locations, traffic conditions, etc. Right? So there will be like one central brain to consider all these different scenarios and then optimize the system throughput based on this environmental factors. And then the last is the shared message pool. I think this part is similar to centralized, but this is like there's no central agent, but this is just all the messages and the environment are shared for all the agents, such as the video game. Like each agent in the video game, if you want to train an agent to play the game, especially the games that require a team, then you want to have the AI there, like it's in a shared world state in the game.
Yeah, the difference between centralized is and that one is centralized has a agent that behaves like the
Behaves like
communicator.
the captain. Yeah.
Yeah. And I think the message pool is more like a bulletin board. Anybody can leave a message there for anyone else to pick up.
Yeah, exactly. And then the each individual agent will figure out, okay, whether that message is useful for me, right? It still needs to own the decision by itself. Well, over here is like the captain already tells you. Captain tells you what to do next.
Right.
Yeah. In terms of the communication content, right now majority are still text. So this is also how well it's hard to say human. Well, majority of the times human communicate with each other in text, while we also present PowerPoints, which can be multimodal as well. For the software development, it's like a code segments, and also for simulation of the games or science simulations, it can be analysis, strategy, suspicion. So this can be all in formats of text there. I do see a trend right now. It's also posed as a challenges to progress the communication message toward multimodalities, especially to images, videos, all right, voice, or those like different modalities. Cool. The basically this diagram is from the Meta GPT X. Again, Meta GPT is not from Meta, so it's just a meta learning. Meta, I think, stands for meta learning. For the first AI software company. So remember that application case. So this is from their paper. That they show how they organize the AI company, like have the architect, project manager, product manager, and the QA, and also engineer. And then this is a shared message pool. So they use a shared message all over here. So like kind of the product manager can send a message to architect. And here is a product manager send from to engineer. Like the product manager send a write task to engineer. And then the engineer, so this is his profile. The goal is to write elegant, reusable, accessible, efficient code. Sounds familiar. And then there will be also constraint that you want to use a PAB8 to make sure that your code meets the standards. And then the engineers will start writing the codes, and then you will try to execute it. There's if it does not pass, you needs to debug. And then the LLM needs to rewrite the codes, make adjustment to make sure the codes can run. If it's executable, and then it will add to its own code base over there. So when the engineer write codes, it will also do the memory retrieval, right, from the historical messages, from the messages the PM sent it to the agent, and also from the past codes that it has to in order to write to complete this task. The last component is the agent's capability to acquire new skills. I think this is a very hard topic, and I don't have a full kind of I don't have a very clear solution to it. It's kind of like reinforcement learning, but right now people also just use the memories as approach to improve the agent's capabilities. So the key ideas is like we want to enable agents to learn and evolve dynamically, just like humans, right? So human is like very naturally to update our neural network in our brain according to the mistakes experience we see. It's very natural for human to update our brain neural network. Well, it's not that straightforward for agent. Um, and then, so basically, the feedback to the agents can come from the environment, right? So it can come from the back after executing the codes from the code interpreter. It can be from the interaction from other agents, like yeah. So like the AI software company, the boss, the boss may provide feedback to the team, to the engineer, and also the human feedback. Like there will be also a few human role in it. Say if an engineer like the codes keep failing, a smart way will be they may also ask for human help, right? And then maybe with human instruction, it will speed up the convergence of writing that piece of code. Yeah, so it can also be no feedback. It's just focusing on the simulations itself. How agents adjust to the complex problems. The very common way right now is by memories. It's kind of just using RAG. type of approach. We just leverage a memory module to store the information from the past interactions, and then when performing the action, performing certain task, they can retrieve the most relevant and valuable memories, especially the successful actions. So people notice that by retrieving the successful stories from the memory is far more effective than retrieving the failures from the memories. I think it's good sign that a human also needs a positive positive experience in the memory so that the human can perform better. At least that applies to me. But especially in the multi-agent, people also discover that by showing success examples, successful like the in context future examples, right? So we want to demonstrate the successful actions from the past can help improve the performance of the agents. There can be also self-evolution. So this is LTC. This paper I'm not sure. So it's in the review paper, but this paper itself hasn't been cited much yet because it also requires retraining of the model. So basically, it's accumulating all the data through all the interactions, and then it's going to fine-tune the LLMs by itself. I also ask about when this type of fine-tuning will become useful. It is when you need really specialized and adaptive behavior that's go beyond current capabilities of the LLM we have, right? So right now the LLM is more like a very general LLM, and even when you try the memory, it doesn't work. Then you may need to consider, okay, whether we can do some this learning through communication paradigm to just train your own smaller agent, like just specialized for the task you need. The third approach is the agent orchestration, is that the system can be dynamic and can generate the new agents on the fly. So this is some example. It's like there's the LLM agent, and then it has a goal, and then it observes something from environment, it take action, and then there's a second observation, second action. And then when it reach like 10,000, the agent will get confused, like what this is about. So one agent may single one will be struggling to replay the full history. The memory idea is uh, instead of put that in the context, right? It's just the similar idea to rack that we want to retrieve the most useful past experience in the past, and then this is your kind of like for the short-term memory, you can also in the context you can also put a few kind of most recent or relevant examples instead of the full length of 10,000 example, you can retrieve the most relevant ones in the context. And then for the 10,000 one, then the agent will less struggle, and then can fully focus on the task. Kind of we help to reduce the noise of the inputs to the agents. People also think that whether this memory is a good memory to save, we can also put an agent there, a right agent to decide, oh, whether this experience will be useful for future actions. If it's nonsense, no point to store them. But if they think, oh, this will add to the knowledge, this will add for the agent to make better action in future, then it will decide to write it to a vector database, which becomes the long-term memory for the agent. And then the next time there will be a read module, kind of the retrieval part in the rack, retrieve the relevant experience from that. There can be also a reflection. So this is how human brain work. People say when humans sleep, it's kind of reorganizing all the memories in the brain and throw away the noise and irrelevant ones. So that's why sleep is very important for humans. So people also say, oh, how about let's also organize the experience in the database, in the memory, and through a reflection. So instead of all this just simple observations, we can also summarize it, right? And summarize the strategies, summarize the ideas and thoughts from that. And then the next time when we make action, then I will just say, oh, this is truly a new skill that I learned from the past to how to take action. So I can just retrieve the most relevant idea or hows from the past to for this to figure out what is action to take for the new observations. I think this is also simulates how human brain work because human memories also needs to be reorganized during sleep. Cool. The last one is agent orchestration. I'm very excited in this field because it's truly the power of multi-agent. It's like it automatically refines itself and figure out where to focus and where to put the basically put a head count. So each agent is like a head count. So where to put the next head count to the system, to the team, so that we can achieve the best performance according to the feedbacks. This is published in March this year. It's like automatic design of agentic system. So I may also plan a meetup on this one, but the key idea is like there's a agent archive of the multi-agent framework, there's an input, and then there will be a meta agent. So meta agent is trying to refine and figure out what is the next interesting agent to spin up, and then in that it will automatically create the profiles for the new agent. Like what is the motivation, what is the name, what is the tools. Maybe for the new agent, the tool it has is the codes. Is a code, right? Maybe it's a reusable code, such as extracting all the rows from the CSV. That the meta agent figures out, oh, I need a tool to extract all the data rows, right, from the Excel sheet. Then it's going to spin up an agent just focusing on that. Basically, maybe that agent is just a Python code, right? To do that. So, oh, and that paper also showed what is the examples of the discovered agent. Some is like a multi-step peer review agent, some is a verified multimodal, and some is divide and conquer agent. So this is it's interesting to see how the meta agent plan the agents by itself, but not by human design. Last, in this paper, they also list all the applications by that time. So majority of that is in 2023. Because this paper is published in 2024, so I guess the landscape fully changed right now. But yeah, I think it's very interesting to see under this framework, such as what is the environment interface, what is the agent profiling, what is the communication paradigm, and how the agent acquires skills. You will see how different applications define the multi-agent framework, right? And over here, you see majority is sandbox, some is physical. Uh, Majority of the agent profiles are predefined, as you see over here. So it's all predefined agent profiles by humans. So this is some profile example, such as CTO, programmer, product manager, engineer, etc. And how the agent communicate with each other. It can be cooperative, it can be debate, and also it can be competitive over here, like the war simulation, like the public administration, so public administration is cooperative. So this is a competitive. So like economics is a competitive agent defined over there. And also what is the structure of the agents network, like layered, decentralized, or centralized over here. So if there's like a requiring a strategy planner, then it's kind of like centralized over here. For example, it requires a strategy planner, then it's a centralized. And also regarding how the agents acquire new skills, new capabilities, majority is memory. See, it's all memory. There's some dynamic generation over here. So it's like online communities, camping fishing. Actually, I don't know what it is. It looks like creating a community for entertainment. I don't know. Or figure out what is the next community to create. So this is like a dynamic generation. Yeah, majority is using memories, just the same with rack to continuously improve the skills of the agent. Yeah. Uh, the next, the paper also show the what are the existing benchmark data sets, right? For the software development, for the science debate, for the gaming, psychology, policy making, etc., and also recommender system. Uh, this data set, I'm not sure. So people also use these data sets just to directly evaluate a single agent. I would say like a very useful benchmark data sets will be really, really challenging that really require a multi-agent framework that can really distinguish the effectiveness of the multi-agent framework. The paper also posed a challenge there because right now the community is still actively developed. So we still need to see to build this open source benchmark dataset so that we can continuously improve the multi-agent framework on those benchmark datasets. Finally, the paper also talk about the challenges and opportunities, right? So as we have talked through like advancing into the multimodal environment, like how we can process diverse data types, and also how the agents can communicate with each other, not just through text, but also to other form. How we can address hallucinations and errors to increase the robustness of the system rather than error propagation throughout the system, which will be a disaster. And how we can acquire the collective intelligence, like how can we learn from the instant feedbacks and yeah, so whether this is sufficient, like the memory and agent orchestration, whether this is sufficient to lead the collective intelligence of the network, I think is an unanswered questions. And we still need to invest the research in this direction to see what is the strategies or theories behind the collective intelligence of the multi-agent network. And also, as you pointed out, how can we scale up it? Because if you scale up the number of agents, the system will also significantly increase the resource requirements. You may end up with lots of API costs. Will be your bill will be larger with the multi-agent system, right? And also, what is the strategies to um, create a harmonious community of the agents so that we can minimize the conflicts and redundancies. It's kind of like how you want to build a most effective team while minimizing the cost, right? I think the mental models shares the similarity of human human system. The last challenge is the evaluation benchmark. I think there's still a shortfall in the development of the most comprehensive benchmarks that truly shows the benefits of the multi-agent than a single agent, right? If a single agent already performing very well on that task, so what's the point of using multi-agent over there? And then the applications and beyond. I think the application is still very new. Even for myself, we are also thinking about whether we can, whether there's some problem that the single agent may not able um, to get the best performance while the multi-agent can help. Right, so I think I see lots of open source multi-agent frameworks, but I think the application side there still needs lots of exploration to see where what type of problems that the multi-agent will be the best fit for. Yeah, that's the end of the today's meetup. So basically, I just want to remember the overall components of the multi-agent system, right? So you understand there will be interface, there will be a profile of the agents, there will be communication among the agents, there will be also how the agents can evolve and learn from the observations. And also, I hope that the examples and I show in the beginning can also excite you up and make you think, like whether the multi-agent can truly be a good fit for your problem. because that really requires that level of complexity uh, there in order for the mass to win over the single agent framework. And again, all the slides have been posted on the GitHub, and also the recordings will be published in this channel. So yeah, I'm open to any questions or comments or yeah, or exchange of experience.